Okay, so just to recap, in video one, we had just this very quick estimation here in terms of the time periods. Again, essential in terms of the formula that we're using here is the we are looking at two expiry dates. So we're trying to run this estimation. It's a model-free implied volatility estimation. It requires estimating the maturity on both a near and then the next expiry dates around a 30-day time horizon. And T here has to be expressed, at least initially, in terms of minutes, because we're trying to get a more precise estimate of time. We don't just count days, but actually we've got to bring it down to the minutes. And that's just to increase the level of exactitude and precision in the overall estimation. Now, if we look at that in terms of how it pans out in the estimation, that means any expiry date, if we identify that right now when we're running the estimation at the time of the calculation, there is a number of minutes until midnight of the current day. There is a number of minutes until the settlement takes place on the final day, and then the number of days, and we've got this expressed that then in terms of minutes for the actual contract, for the near and then the next contract. Okay, so in terms of then getting this 854, let's look at that 854 again. Where is the 854 coming from? Well, it currently is 9:46 a.m. in the morning. That would imply it's currently 10 o'clock, or it's close to 10 a.m. right? If it's currently 10 a.m., how many hours are left in the day? There are 14 hours left in the day. If we express those 14 hours in terms of minute, we just multiply by 60. That would give us 840 minutes. And because it's not 10 a.m. exactly, it's actually 9:46. There's 14 minutes between 9:46 and 10. So we add that to the 840, and that brings us up to 854. So if you like, this 854 here in both the T1 and T2 represents the number of minutes remaining in the current day until midnight, until midnight of the same day, right? So to bring us up to 24 hours, there's 854 minutes in the current day. That's true of T1 and T2. Then we would expect then for the settlement day, we would have equivalent amount of time for both periods. It actually turns out it's not the case, because there are both weekly S&P 500 options and monthly S&P 500 options. And when there's a weekly S&P 500, we don't have a monthly. And when there's a monthly, which is normally the third Friday of the month, then we don't have weekly expiry. Okay, so and that means then the settlement for if we look here, minutes from midnight until 8:30 for standard S&P/X expirations, are minutes from midnight until 3 for weekly. So if the settlement is weekly, right, if the contract we're dealing with is a weekly contract, its settlement is at 3 p.m. If it's a monthly contract, its settlement is at 8:30. Okay, so we're taking here that standard means monthly, and its settlement is at 8:30 in the morning. And for weekly contracts, unusually, the settlement is at 3 p.m. that day. Okay, so for the earlier period, we have a monthly contract. So at the closest expiry, there's a monthly contract. It's 8:30, but 8:30 represents 8.5 hours, so 8.5 hours. And if we multiply that by 60, we take that 8.5 and multiply by 60, So to convert the hours to minutes, 60, we get 510, and that's where that 510 is coming. If we take 3 p.m. in the afternoon, then that's 3 plus 12 is 15, so that's 15 hours have passed. And if we take those 15 hours and multiply, so in fact we just write 15, we take 15 and multiply by 60 minutes in the hour, that gives us 900. So that's where the 900 is appearing here. And then in terms of the last figure here, in terms of the minutes, we have 34,560, and then for the second one, 44,640. In this particular instance here, what do we have? How many days until expiration? The number of days until expiration is, there's 25 days for the close, the nearest contract, and then 32 days for then the following contract. If we say there are 60 minutes in the day and 12 hours, that's how many minutes we have. So there's, if we take a look at that for a second, if there are actually 24 hours in the day and 60 minutes, then there's 1,440 minutes in any given day. And then when we multiply, when we take 25 days and express in minutes, right, 1,440 minutes in any given day, then we have 36,000 minutes. Okay, so but we've got to note as well, of those 25 days, we've used up 1 day from in terms of these other numbers that have been estimated. So in a 25-day expiration, we have the current day and the settlement day, and we should then think in terms of full days, there are 24, and that then, when expressed in terms of minutes in the other days, that gives us 34,560. Okay, likewise here for the longer dated contract, we are told that it's 32 days. Again, if we take that 32 and multiply by the 1,440 minutes in each day, that gives us 46,080. But of course, we've got to note that we are just 1 day less in the settlement, and the current days that are already included. Then we have to take out a day, and that brings us back to the 44,640. 44,640. Only thing that remains then is, where are we getting this 525,600? Well, we could say, let's think about this for a moment. There are 24 hours in a day. There are 60 minutes in an hour. There are 365 days in a year. So there are 525,600 minutes per year. Okay, so we then have got to say how much time in minutes for T1. So if we were to estimate T1, then T1 would be equal to the number of, first of all, the number of minutes in all the other days. Okay, so that's the 34,000. And we have the 510 minutes, so 510 plus we have the 854. Okay, and when we divide that by the number of, when we take that figure and divide that by the number of minutes in a year, we get 0.0683, okay, and then for T2, again, we do likewise. How many minutes in the other days? How many minutes in the other days? They're 44,000, so it's equal to 44,640 plus, well, in the current day, there's 854 minutes. We've already established that. And then in the settlement day, well, we run to, in the longer maturity contract, we run to 900 minutes. So we've got to include in the 900 minutes as well. Let's tot those up, 46,394. When we divide that by the number of minutes per annum, right? When we divide by the number of minutes per annum, we get 0.0882. 0.882. Okay, and that's just a little misprint here on this document. So when we work out, just a note on the SIBO's T2 figure here, it's not 0.88, it actually should be this 0.0882, and that would make sense. Remember, the first contract is 25 days, the second contract is 32 days. This figure, this time period is 10 times greater than this one. That looks a little bit bizarre. It is bizarre. The true figure here is 0.0882. Okay, now just to check that, I'll go back to the original, if I can find the, yeah, I have here. This is, again, if we come down, okay, so that's where we've done the estimate here. That's what's reported in the VIX document. When we go a little bit for T2, when we go a little bit further into the estimation, we can see that misprint then is corrected. So for T2, we have down here 0.08826. Okay, so in the next part of the estimation then, what we've got to set out, if we follow in line with the steps, we've got the T1 and T2, and we then have to proceed and estimate F, right, for out of the data that's in place. Now, the CBOE did provide the full range of data. Let's just go in and look at what's referred to here as Appendix 1. So the data that we have to use in terms of estimating the VIX for this particular estimation provided by the white paper entails looking at, this is the near term option, this is the next term. So if we had mentioned that there was the 32-day contract and the 25-day contract, okay, what are we referring to? Well, this is the 32-day contract, this is the 25-day contract. What do we have in terms of our data? We have different strike prices. So consistent with other implied volatility estimates, we have an array of strike prices going from 800 up to 2,250. And that's for the near-term contract, the 25-day contract. For the next day contract, it is 32 days. Again, we have a similar array of exercise prices. Now note we have data for the call and the put, bid and ask, for both set expiries. And in the next video, I will proceed to go to the next step of the estimation.